Hello and welcome to the section 9.3 lecture today. Today we're talking about solving systems of equations by elimination. So let's go ahead and jump right into it because some of the problems today could get a little long-winded. I don't want the video going super long like last time, so let's go ahead and jump right into it. Solving a system of equations by what we call linear combinations. And this is kind of a modified, well, not a modified, but a different way to talk about elimination. It says to arrange the equations with like terms in columns. So the way that I think about that is x's, y's, equal signs, and numbers all stacked. That's what they mean by in columns. So stack all those things. Then we want to multiply one or both of the equations by a number to obtain coefficients that are opposites for one of the variables. Yikes. Okay. I kind of go over, or I kind of think of this in multiple ways, but this is a kind of one size fits all. I'll talk about some different ways to do this, but sometimes you'll need to do this, sometimes you won't. That kind of goes for all these steps, at least steps 1 through, I guess just steps 1 and 2 may have to happen. It says to add the equations. I still think about add or subtract the equations from step 2. Combining like terms will eliminate one of the variables, and you want to solve for the variable that's left over. And so I guess to say that I am looking for add or subtract, I'm either looking in step 2 for opposites or the same coefficients. And I'll talk about that once we see a problem. And then we want to kind of do what we did yesterday. Once we have one of the answers, find the other answer. You know, we don't want to just shoot from the hip and say, well, it's somewhere in the x equals 5 line. We don't want to just pick on that. We want to find both values. So here's where I'm talking about using addition or subtraction. I have an example of both. And so the thing that I notice here is that when I'm looking at this one, I have opposites on my y's. Okay, my y's are set up as opposites. So I'm going to add those two equations. And when I do that, 3x plus 6x, that's 9x. Negative 9y plus 9y, we could say is plus 0y. But 0 times anything is 0, so we actually just don't write that. And in this case, I'm just going to cancel it out and pretend it's not there. And then on the other side, negative 6 and negative 12 is negative 18. And so now the equation I have says 9x equals negative 18. That's an equation with one variable that we would just love to solve. And I get x is equal to negative 2. Now, a lot of people like elimination more than substitution because of this idea right here, that I already have one of my equations or one of my values. And we found out yesterday that in substitution, this section was the harder part. Finding the first one was the harder part. So people always get excited that, oh, elimination, I only have like 2 steps and then I know one of the values. That's pretty good. It is and it isn't. That's my way of saying that. It is and it isn't. Because now I have a harder thing to do. Now that I know one of the values, I need to find the other one. And you'll notice that I don't have an equation that says y equals 5x plus 2. So I need to use this in one of these equations, and I'm free to use whichever one I want. I'm going to pick the top one. And we'll see where this is kind of where that trade-off comes into play. And now I have a little bit harder work to do. Because now I have to solve an equation to find my second variable. 3 times negative 2 is negative 6 minus 9y equals negative 6. If I add 6 to both sides, I get negative 9y is equal to 0. And then dividing by negative 9, I get y is equal to 0. So these two lines cross at negative 2, 0. Okay, but again, that was addition because my coefficients on y were opposite. On this one, my coefficients on y are the same. They're both -7. And that's okay. One method that the above picture suggests you do is to multiply one of the equations by like -1 to flip the signs on everything. For me, I'm just going to say let's not do that because that's another step where we can make a mistake, and I'm just going to subtract. Now, the trick here is that I have to think about x minus 3x. Not too bad. X minus 3x is -2x. 7 minus -7 would turn into, -7 minus -7 would turn into -7 plus 7y. And so that would be 0y. And then below I have -24 minus -16. And this is the difficulty with the subtraction, is that I have to think about this as -24 minus -16. That would turn into addition, and that would give me -8. Okay, from here I'm just going to divide by -2, and I'll get, I don't know what I'm doing. I don't know what I'm writing. X is equal to 4. So I have x is equal to 4. Now I need to figure out what y is. And I can choose either equation. Both of them have their ups and downs. I'm going to pick the top one. 4 minus 7y is equal to -24. I'll subtract 4 on both sides. And again, this is the area where the trade-off happens, right? The first one was easier to find. The second one's a little bit harder. -28 dividing by 7 gives me y is equal to 4. So I get that these two lines cross at 4, 4. Why don't you pause the video and try these two? So hopefully I had a chance to do that. Whenever I look at a problem and I want to use elimination, I have to go into it with a plan. And I look at this one and say, well, my y's are opposite. So if I add them, my y's are going to cancel out. They're going to eliminate. We're eliminating a y out of the original equations. So -8 plus -1 is -9. And then -17 plus 26 is going to give me +9. Dividing by -9 gives me x is equal to -1. I'm halfway done, sort of, right? And so I get a lot of people that when they're doing elimination, they just love canceling those out. But the problem is I need those again. So rarely do I cross those out. I don't like to, okay, because I do need to see them again. I'm going to pick on the bottom equation just because numbers are smaller. And so I get -1 minus 5y is equal to 26. -1 is going to give me +1. That's not going to switch that to a plus, though. Minus 5y is equal to 26. When I subtract 1 on both sides, I'll get 5y is equal to 25. And dividing by -5 as my last step is going to give me y is equal to -5. So I get the point where the two lines cross as -1, -5. Even though we're looking at an algebraic method, I still want us to think that this is where these two lines, if I were to graph them, it's where they would cross. And we can definitely see in this one, I wouldn't want to graph this. I'm going to have, if I cover up my y, I'm going to have an x-intercept at 17/8. That's ugly, okay? Not only that, but if I cover up y in the bottom one, I get an x-intercept of -26, right, if I divide by -1 on both sides. So that means I need a pretty big graph, and these two lines just cross at -1, -5. So keep that in mind, that graphing may not always be the answer. All right, hopefully you took a look at this one also and said, well, I have the same number for x's, so if I subtract those, 2x minus 2x is going to go to 0, 0x. But here's the tricky part. Now I have to think about 4 minus negative 2. That's not 2y, that's going to be negative 6y. And the problem with this one is if you put 2y, you'd still get a good number out here as an answer. You'd get a whole number answer, but you'd be a little ways off. Negative 22 minus 26. So that's going to be a negative 48. And if I divide by negative 6, I'm going to get y is equal to 8. So on the same hand, if you got y is equal to 24, then check this part. Right? Check this part that you have negative 6y. All right, now that I know what y is, I'm going to plug it into an equation. I might as well pick the bottom one. There's more positives, I guess. No, there's not. Yeah, I don't know why, but it's totally up to you on which one you pick. Minus 2 times 8 is equal to 26. 2x, and that's going to be minus 16 is equal to 26. When I add 16 to both sides, I'm going to get 2x is equal to 30, 42. Is that right? Yeah, that's right. And when I divide by 2, I'm going to get x is equal to 21. Definitely not one I want to graph, considering those two lines cross at an x-coordinate of 21. So 21, 8. That would just have to be a really big graph to fit all that. Sometimes they're not always the nicest to us. Sometimes we have to multiply one of the equations or both of the equations to get them set up to eliminate. So in this first one that I have here, I notice that I don't have any that are going to eliminate if I just add or subtract. If I add the equations, I'm going to get 9x plus 3y is equal to 3. That still has an x and y, so that's no good. But I do notice that I can turn a 9 into an 18, and I kind of think of this like finding common denominators, right? I want to multiply this top equation by 2 to turn that negative 9 into a negative 18. And so I draw a little arrow over and I tell myself what I'm going to do on the top or bottom of this arrow to keep my work kind of in line and to let me know what I'm doing. So this is going to give me negative 18x minus 14y is equal to negative 38. I just multiplied all those things by 2. And I'm doing nothing to the bottom equation. That's still 18x plus 10y is equal to 22. Now I notice I have opposites here, so I'll add. And the negative 18 plus 18 will cancel itself out. It's going to be 0x. Negative 14 plus 10 is negative 4y. And negative 38 plus 22 is going to be negative 16. And so I'll divide by negative 4. And I'll get y is equal to positive 4. Now that I have one of them, I need to find the other one. And really here, I have 3 equations to pick from. I can pick equation 1, equation 2, or even my modified equation 3. The thing is, with my modified one, it's never going to be that nice because I've made all the numbers bigger. So if we like to kind of work in the smaller number realm, number 3 is never the nicest one. And then from here, you kind of have options, though. 1 or 2 are both, they both have their positives and negatives. Play on words there. I'm going to pick the top one. Negative 9x minus 7 times 4 is equal to negative 19. And so negative 9x minus 28 is equal to negative 19. When I add 28 to both sides, I'm going to get negative 9x is equal to 9. And when I divide by negative 9, I'm going to get x is equal to negative 1. So these two lines cross at negative 1, 4. Excuse me. In my next one here, I can go ahead and I'm going to have to multiply both equations by something in order to get stuff to cancel out. And again, I think of it in that common denominator realm. So I'm going to think about, and I mentioned before that we always want to have a plan, and I'm going to think that I want to eliminate x's. Okay, so to eliminate x's, I'm going to multiply the top equation by 3 and the bottom equation by -2. I'm actually going to set it up to where I get to add them. If I have to multiply them already, I might as well do the work to make my life a little bit easier because I do like to add versus subtract. So 3 times 2x is going to be 6x. 3 times 5 is going to be 15y. And that'll be -30. On the bottom, I'll have -6x minus 6y is equal to -24. And this will let me add my equations together. 6x minus 6x is 0. 15 minus 6y is 9y. And -30 plus 24 is -54. Well, that works out okay because when I divide by 9, I get y is equal to -6. And now here's an issue, or here's a point where I really have 4 options. 1, 2, 3, 4 that I can pick from. 3 and 4 were both made by making my numbers bigger, so I don't really like that. We'll pick on number 2, the bottom one here. Plus 3 times -6 equals 12. 3x minus 18 equals 12. And if I add 18 to both sides, I get 3x is equal to 30, which tells me x is equal to 10. So I get that these two lines cross at 10, -6. Go ahead and pause the video and try these two at the bottom. Hopefully you had a chance to do that. Let's go ahead and see how you did and what you chose to do. You could choose something totally different than what I'm doing. If you like canceling x's, you're actually going to work a little bit harder in this one. I'm going to choose to cancel my y's. I'm going to multiply the top equation by -2. To get this to be a +14 to cancel out with that -14. And again, maybe you chose something different. That's totally okay. And that's going to be 58. Yeah, +58. A little bit scary with the bigger numbers, but that's okay. Oops, that's a 14y. Let me write that in there before I forget it. 58 minus 14y is equal to -23. And now we can go ahead and add the two equations. That's going to give me -7x. Let me just double check that. 58 minus 23, 35. Okay. That works out pretty well. If I divide by -7, I get x is equal to -5. Okay. So I get x is equal to -5, and we can go ahead and put that in the, I guess let's go with the bottom equation, even though there's a lot of ugliness in that equation. Now I get +5 minus 14y is equal to -23, which looks like it's going to work out pretty well. If I subtract 5 on both sides, I get -28. And dividing by -14 gives me y is equal to 2. So I get -5, 2. Again, if you did that problem a different way, that's awesome, especially if you got the same answer. Oops. In this one, I got to multiply both of them by a certain number. to get things to work out, to get things to cancel out. And I can really choose either one, but I'm going to go ahead and choose to multiply the top one by -7 and the bottom one by 2. My plan is to cancel out the x's, and remember, always have a plan. So we have 2 times -7 is -14x. -7 times 9 is going to be -63y. And we're going to get positive 14 over here. On this one, I'm going to get 14x. And 2 times 6 is going to be plus 12y. And 7 times 2 is going to be -7 times 2, -14. If you're really clever, you can see that you don't have to think too hard on this one, but it does take a little bit of experience. I'm going to act like I don't know what's going on. I do need a version of 63 minus 12. Okay, 51. Sometimes I'd be a little bit concerned here, but -14 plus 14 is going to be 0. This is going to be -51y, which is a little bit scary until I look here. 14 minus 14 is 0. 0 divided by anything is 0, so my y value is 0. I would heavily recommend not picking one of these two equations. Let's go ahead and pick on one of the other ones. 2x plus 9 times 0. Oops. Wrong order there. 9 times 0 equals -2. 9 times 0 is 0. So 2x is equal to -2, which tells me x is equal to -1. A lot of work to get a pretty simple answer. Anyways, good job today. If you have any questions, make sure you put them over there on the left side. Otherwise, I hope you have a great day, and we'll see you in class.